Doing example 2, section 5.1. So hopefully you read about critical numbers and the first derivative test and how you determine where a function is increasing or decreasing using the derivative. So as you've hopefully read about, minimum and maximum values occur at critical numbers, and a function can change from increasing to decreasing at a critical number. So really when you're asked to figure out intervals of increase and decrease, it's all about the derivative. So that's definitely what we want to find first. So we get minus 3x squared minus 4x plus 15. And to find these critical numbers, there's two kinds of critical numbers. There's the kind that you get where the derivative is equal to 0, and then there's the other kind that you get where the derivative doesn't exist. This derivative is a polynomial. It is defined for all real numbers, so it will always exist. So we're not going to have that kind of critical number. But we will probably have the other kind. That occurs when the derivative is 0. So the way we find that one is we take the derivative and we set it equal to 0. And then we solve the resulting equation. Whatever x values we get, those are going to be the places where the derivative is 0, and hence the critical numbers. So to solve this type of equation, we want to remember that it's usually more useful when we're factoring, or easier when we're factoring, to not have a negative leading coefficient. So we can multiply this whole thing through by -1, and we'll get 3x squared plus 4x minus 15. Now if I'm really multiplying both sides by -1, but if I multiply the right side by -1, I just get 0. So what we're going to find is that this factors to be, let's see, we're going to get a 3x here and an x here. That's what's going to get us the 3x squared. And then we've got 15, and we have to end up with 4 there. So probably we're going to have some combination of 5 and 3, and we'll just have to guess it and check it and make sure that it works. So let's try to put the let's put a plus 3 here, and let's put a minus 5 here and see what happens. So that's going to give us, as our inner term, 9x. That's when you do FOIL, it's the outer one that we're looking at here. It's going to give us 9x, and then the inner term, the I in FOIL, is going to be a minus 5x, so we're going to get plus 9 minus 5. That's 4. And then the minus 15, we'll have a minus 5 and a plus 3. That gives us the minus 15. So this is the way that thing's going to factor. Really, remember when you're factoring something that has a leading term that's not 0, that's not 1, you kind of have to use this guess and check. So you pick all the factors of this one, put them here. There's really only 2 factors of 3, so we only had one choice there, 3 and 1. And then here, we pick the factors of that one, 5 and 3. Since that's negative, one had to be negative, one had to be positive. So 5 and 3 were really the extent of what we had for 15. So we could have possibly reversed them, changed the signs, but really it's guess and check, so you play around with it until it works. If the 5 and the 3 hadn't worked, we might have gone to 15 and 1, but usually that's not going to happen. So anyway, we've got these two things set to 0. So we set them separately to 0 to find those critical numbers. So we're going to get, if I add 5 to both sides and divide by 3, get x equals 5/3. And then if I subtract 3 here, I get x equals -3. It says that we're trying to find the intervals of increase and decrease. The way we do that, and this is really leading to the first derivative test, although this question is only asking for increase-decrease intervals, we'll go ahead and make this table. That's what we're typically going to be doing with this kind of thing. So we basically take the domain of the original function, which in this case it's polynomial, so its domain is all real numbers, and we go up to the smallest of the 2, or however many critical numbers we have. And then we go from that critical number up to the next one, and then we just keep doing this until we basically run out of critical numbers. We want to make sure that as we go from left to right, that all the numbers that we see are increasing. Okay? And then finally up to infinity. So this table is going to help us to answer the question. So then what we're going to do is we're going to find some test values Okay, so we put the test values on our first row here. And we want to, for the test values, we just want to pick a number that's on the interval. So here I'm going to pick -4, since it's on the interval from -infinity to -3. If the interval includes 0, as this one does, 0 is always a good choice. And then 5/3 to infinity, we'll pick 2 for that one. You just have to make sure that whatever test value you pick, it has to be on the interval that you're looking at. Okay, so just make sure that that happens. And then what we're after here is the sign of the derivative, sign of f prime, because that's what this first derivative test sort of is going off of. The sign of the derivative determines whether the function is increasing or decreasing. If the derivative is positive, the function is increasing. If the derivative is negative, the function is decreasing. So that's why we're doing this. We're trying to decide what is the derivative, what sign does it have. So what we're going to need to do then is take these values and plug them into the derivative. So here is the derivative. That's what we're interested in. Okay, so I'm going to start with 0 since it's easier. If I plug in 0 here, notice what happens. That's 0, that's 0. I'm left with 15. 15 is a positive number, so the derivative is positive. Okay? For the other ones, you can use your calculator, whatever you need, but just be sure you're careful here. We have to get this right as far as the sign is concerned. If I plug 2 in here, 2 squared is 4 times -3, that's -12, and then I'm going to have another -8, -12 minus 8 is -20, and then I'm going to have a +15. That's clearly a negative number, and that's all that matters. We don't even care what it is, we just care what is the sign. And I think that you'll find when you plug in -4 here, again, be careful when you're squaring the negative, that becomes then +16 times the -3. So that's going to be like -48. And then +16, two negatives multiplied together, +15. That's going to be negative as well. So we get two negatives and a positive. What does this tell us? So on the last part of the table, we're going to make our conclusion based on the sign of the derivative on each of these intervals here. The conclusion that we want to make here is, since the derivative is negative, what is the function doing? It's decreasing. Okay? It's acceptable just for shorthand. You can just put a down arrow for decreasing. If it's positive, it's increasing. And then again, if you just want to do shorthand here, you can put an up arrow for increasing. And then here it's decreasing again. So really, this answers the question. The question was, on what intervals is the function increasing and where is it decreasing? So what we can say is it's increasing on the interval from -3 to 5/3. Now, remember, this is not a point. This is an interval notation. It's increasing on that interval. And it's decreasing on the rest of these two intervals here. So decreasing from -infinity up to -3, and then we put that union to say that we're joining that with another part of the interval here, so that's 5/3 up to infinity. Okay, so now this question only asked the intervals of increase, decrease, and we've answered that question. Okay, but just keep in mind that what we're going to do very soon, we're going to take more from this table. We're going to get more information from this table. That's where the first derivative test is going to come in. Since the function changed from decreasing to increasing, that tells us something. If it's decreasing and then it's increasing, well, what happened at that critical number? Well, that means we have a minimum value there. If it's increasing and then it changes to decreasing at that critical number, 5/3, it was increasing, then it's decreasing, and we have a maximum value at that other interval. At that other critical number. So now the last part of this says to graph this function, and I don't have too much room left to do that, but you can do that on your calculator, or let's see, I've got it saved here. I can just do a quick sketch of the graph. I can fit it right here. Now, and you're totally welcome to use your graphing calculator here. What I see is that it reaches, as we thought, it reaches a minimum value at -3. So I'm just going to go ahead and say that this is -3 right here. And then it reaches a maximum value at 5/3. So I'm just going to say that maybe this is 5/3 right here. I don't need to be too precise about this. We're going to get into more of this graphing later. But on our calculator, what we should see is something like this. If you kind of have to zoom out on this to see this, but it reaches a maximum here. It's going to do something like this. And that's characteristic of a cubic function. For the window here, just be aware that this goes up pretty high. I think I have my window set at 60 for the maximum up here, and then minus 60. So if you really want to see this, you're going to want to set your x min to be like maybe minus 8, your x max to be like maybe 8, and then the y min should probably be around minus 60. The y max should probably be about plus 60. But really, for the purposes of what we're doing here, we just want to notice what's happening at these critical numbers. We have a maximum here, we have a minimum here. That's where we're going to be going for most of the rest of this section.